So welcome to this fourth tutorial in 303 heat transfer. Today we'll be talking about unsteady heat conduction. You may already have seen the tutorial questions. So the first one is number 5.3 from the textbook. So in this case we have a microwave oven that operates on the principle that you have high frequency wave heating food from the inside. So this situation can be considered as a uniform generation of thermal energy inside the body. Whereas as opposed to the ovens, as opposed to the microwaves, you have conventional ovens which heat the body from the outside through convection, and then the heat has to transfer to the inside using conduction. Okay, so you have in this example you have a slab of meat that is being heated. So the slab thickness in this case is given as twice of L, and in each case the meat is to be heated from 0 degrees centigrade to 90 degrees centigrade. Okay, so what we have to do is we have to sketch the temperature distribution at selected times for each of the cooking processes. Okay, so for each of the two processes we have to roughly sketch the temperature profiles in the meat layer. We particularly have to consider like the initial time T0, and then an intermediate time T1, and then T2, which is final time at which the stuff gets heated, and then we have to consider time T3, which is basically when you after T2 you start the cooling process, and then the slab starts to cool, and we have to sketch the temperature at some time later time T3 as well. So let's do that. Okay, so you have this slab. Okay, I'm exaggerating this. So you have this slab of thickness 2L. Now for the first case, which we'll say, let's say you have the blue color for oven. So the oven only heats on the sides. So what will happen is when you have the initial time, of course the temperature of the whole thing is at 0 degrees centigrade as it was given. So I'm plotting the temperature on the x-axis. So that's my temperature, and this is my let's call it x. This is T1. Sorry, it was given as T0, and then at a later time when the this is conventional oven. Okay, sorry. So at a later time what will happen is that the amount of heat from the sides, it will take some time for the energy to seep in, so and there will be a conduction resistance as well. So what we see is the temperature is higher here, but then it will be lower, and since the whole thing is symmetric about the center plane, so we'll have the same thing going like this. So the temperature profile will be something like this. Okay, so this is at T1, and then at T2 the temperature of the sides will increase further, and again you will have some sort of a variation like this um, from the sides because you're heating, or if the sides have become really hot, then in that case you will see something like this. That's T2, and then when the thing starts to cool, then what will happen is that the cooling will also be prominent from the sides, and the inside will still remain hot for a long time, and that is what you see in food. So after some time the inside is quite hot, but the outside has become cold because the outside boundary conditions now are the ambient conditions, which are now cold. So at a later time you will see that the boundaries will be at a lower temperature, whereas the center may still be at some temperature like this. So this is T3. Okay. Now for the other case, where we have our microwave oven. So in that case, since the heating is happening from the inside, well, initially at temperatures the same everywhere, 0 degrees centigrade, but since the heating is happening uniformly, then what you would see is a profile which will look almost flat, and that is typically what happens in a microwave. The body, the food parcel gets heated uniformly. Of course, there's a directional nature of the microwave oven, but things rotate anyways inside the oven. So you'll have a T1, and then after another time, the temperature of the whole thing will increase uniformly. And when things start to cool, now in this case, there is no uniform heat generation. There is just cooling from the boundary. So we have conduction and then convection from the sides. So then the profile still will look like what we had T3 in the last time. So the sides will cool much faster than the inside. So we'll have something like this. So that's our T3. So this is exactly what was asked, to plot the temperature profiles for this situation. So one has to have some sort of a feel of the phenomena as well, in addition to being able to solve equations and numerically solve the problems. Okay, this is one of those cases.